Hey everyone, in this video we are going to derive the quadratic formula step by step using completing the square. So let's break it down and make it simple. So our quadratic equation in the standard form is ax square plus bx plus c equals 0, where a is not equal to 0, because if a is 0 then this reduces to just a linear equation of degree 1. So my equation is this: ax square plus bx plus c equals 0. My first step is to make the coefficient of x square as 1. And how we will do that? By dividing the entire quadratic equation by this a. So I would get ax square divided by a plus bx divided by a plus c divided by a, and whatever we do on the left side we do the same on the right side also. So 0 divided by a. So a divided by a is 1. So my equation becomes x square plus b over a x plus c over a equals 0 divided by a is 0. So my first step is done, where I made the coefficient of x square as 1. My next step is to transfer this constant term c over a to the right side. So x square plus b over ax equals minus c over a. Notice that when this will be shifted to right side, plus would become minus, the signs change. My third step is to write the left side as the perfect square of the binomial, and that's the most important step. That is why we are deriving the quadratic formula by completing the square method. I would be making a perfect square on the left side, and to make that perfect square I would be adding a term or a number on both sides of equal to sign. What that number is, that is always equal to the coefficient of x divided by 2 whole square, always. Now what is the coefficient of x in this equation? It's b over a. So it's b over a divided by 2 means 2 over here. So I would be adding b over 2a whole square to both sides of this equation to get a perfect square on left side. So let's do that. So I would be getting x square plus b over ax, these two terms. And now let me add this term on both the sides. So it's b over 2a whole square on this side equals minus c over a plus again this term on right side. So b over 2a whole square on this side too. Now, if you will look closely, this left side is the perfect square of the binomial term. And what is that binomial term? That binomial term is this x plus always this term which we have just added, b over 2a. So it's x plus b over 2a whole square. So we have written the left side as the perfect square of this binomial term equals minus c over a plus b over 2a whole square. Let's simplify it. So b square is b square and 2a square will be 4a square. So now the next few steps will be simplifying this right side. Sorry. So I would be getting x plus b over 2a whole square equals, what is the common denominator of a and 4a square? Look closely. If I multiply this a with 4a, I will get 4a square. So if I am multiplying the denominator, I'll multiply the numerator as well. So I get minus 4ac on this side, and this a times 4a is 4a square, and I would not do anything on this side because my denominator is already 4a square. So my left side is still the same, x plus b over 2a whole square equals, now the denominator of both these fractional algebraic expressions is same. So my common denominator will be 4a square, and over there I'll get minus 4ac plus b square. Let's rewrite it as x plus b over 2a whole square equals, I would write b square first and then followed by minus 4ac over 4a square. Now, how to get rid of this square sign? I would be taking square root on both the sides. So when I would take square root on this side, I would get this on left side. And when I will get square root on right side, always remember the square root always gives us two values, positive and negative. So this is positive, negative, and b square minus 4ac over 4a square. All right, I'll be continuing in the next slide. So my last step was x plus b over 2a whole square and square root of this equals plus minus square root of b square minus 4ac over 4a square. Now, this square root and square will cancel out each other. So, I would be left with x plus b over 2a equals plus minus square root of b square minus 4ac as it is. But I can clearly take the square root of this 4a square and that would give me 2a. How? Square root of 4 is 2 and square root of a square would be a. Now I want to solve for this x. So let's isolate the x by shifting this b over 2a to that side. This b over 2a has the sign of plus, so that it will go on that side. It will be minus b over 2a plus minus b square minus 4ac under the square root over 2a. Notice that the denominators are already same. So x is equal to minus b plus minus under the square root b square minus 4ac divided by 2a. And this is the quadratic formula to find the solutions or roots of the quadratic equation. So x is equal to minus b plus minus square root b square minus 4ac over 2a. And we will get two values of x by considering first plus sign, and in the second time we will consider this minus sign, and so we will have two values. Now this b square minus 4ac, the quantity which is coming under the square root, this quantity is called as discriminant. So let's take a look at this one. The quantity b square minus 4ac is called the discriminant and it is denoted by the symbol delta. So it is discriminant and it is denoted by the symbol delta. So delta is equal to, or discriminant is equal to, b square minus 4ac. So if this delta is b square minus 4ac, I can rewrite my quadratic formula as x equals minus b plus minus square root of discriminant delta divided by 2a. So whenever you are solving the equations, you can first find out this delta or discriminant by b square minus 4ac formula, and then you can find the values of x by this formula, and this is called as quadratic formula to solve the quadratic equations. I have another video where I have taken 4 or 5 examples in which I am solving the quadratic equations by using this formula. I'll put the link here. Please check out that video too. Now, I want to explain further about this discriminant quantity because this is a very important quantity. So, this discriminant, which is given as b square minus 4ac, this is called the discriminant of the quadratic equation. This discriminant is very useful because it helps us to decide or to find out that what kind of roots or solutions the quadratic equation will have. So, if this delta value or the discriminant value is coming out to be greater than 0, like positive, then the equation, the quadratic equation always have two roots. So, the equation has always two real distinct roots. Distinct means different, distinct roots or solutions, and those roots are given by x equals minus b plus square root of delta over 2a, and the another one will be x equals minus b minus square root of delta over 2a. If this discriminant is equal to 0, then the equation, the quadratic equation has only one root, has only one solution, and that root or solution is called as repeated root, and that repeated root is given as x equals minus b over 2a. So we have just one solution. Suppose the solution is like 5, then that's a repeated root, means 5 and 5 are the solutions of that equation. Now if the last case, if this delta is less than 0, then the quadratic equation has no real roots. Okay, so it has no real roots means it has no solutions in the real system. So why is it so? Because when delta is less than 0, then in my quadratic formula, sorry, if delta is less than 0, then in my quadratic formula this will be like less than 0. Suppose delta comes out to be minus 7, so it will be minus 7 over 2a, and square root of a negative number does not exist in the system of real numbers. So if delta is less than 0, the equation has no real roots. So, what we have learned so far, that the discriminant is delta given by b square minus 4ac, and the roots are given by the quadratic formula minus b plus minus square root of delta over 2a. If delta is greater than 0, you have two solutions of x minus b plus square root of delta over 2a, and the another one will be minus b minus square root of delta over 2a. If delta is equal to 0, then we have just one repeated root, which is given by this. And if delta is less than 0, the equation has no real roots. That's all. So thank you for watching this video. In my next video, I would be taking one question and I would be solving that question by all the three methods, by factorization, by completing the square method, and by quadratic formula as well. So thank you for watching this, and if you have liked that video, please subscribe to my channel. Thank you. Bye-bye.